NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math lesson. Today we're going to learn how to solve incomplete quadratic equations, specifically when both b and c are equal to 0. Let's start by recalling the general form of a quadratic equation. The general form is ax squared plus bx plus c equals 0, where a, b, and c are constants and is not equal to 0. In this lesson, we'll focus on a special case, when both b and c are equal to 0. This means our equation simplifies significantly. Let's look at an example to understand how to solve this type of equation. Step 1. We start with our general quadratic equation. Ax squared plus bx plus c equals 0. Step 2. We substitute b equals 0 and c equals 0 into our equation. This gives us ax squared plus 0x plus 0 equals 0. Notice how the terms with b and c become 0. Step 3. We can simplify our equation by removing the 0 terms. This gives us ax squared equals 0. Step 4. We divide both sides of the equation by a. Remember, a cannot be 0, because then we wouldn't have a quadratic equation. This gives us x squared equals 0. Step 5. To solve for x, we take the square root of both sides. The square root of 0 is 0, so x equals 0. Step 6. We note that this solution, x equals 0, is a double root or a repeated root. We can write this as the set containing x equals 0 repeated twice. In conclusion, when we have a quadratic equation where b and c are both 0, meaning ax squared plus 0x plus 0 equals 0, the solution is x equals 0, which is a double root. This means the equation has only one solution, but it occurs twice. Let's summarize what we've learned today. When both b and c are 0 in a quadratic equation, we have ax squared equals 0. The only solution is x equals 0, and it's a double root. This is a special case of incomplete quadratic equations that simplifies our solving process significantly. Remember, this technique applies only when both b and c are exactly 0. Let's start with our first example. Here we have the equation 3x squared equals 0. Let's solve this step by step. First, we'll rewrite this as 3x times x equals 0. Next, we'll use the zero product property, which states that if a product equals 0, then at least one of the factors must be 0. So we can say that either 3x equals 0 or x equals 0. From the first case, if 3x equals 0, we can divide both sides by 3 to get x equals 0. From the second case, we already have x equals 0. So we have the same solution from both cases. This tells us that x equals 0 is a double root of our equation. Therefore, the equation 3x squared equals 0 has the solution x equals 0, which is a double root. This means that the solution x equals 0 appears twice when we factor the quadratic equation completely. Let's move on to our second example. Here we have the equation negative square root of 5 times x squared equals 0. We'll solve this using the same approach. First, we'll rewrite this as negative square root of 5 times x equals 0. Next, we'll apply the zero product property again. So either negative square root of 5 times x equals 0 or x equals 0. From the first case, if negative square root of 5 times x equals 0, we can divide both sides by negative square root of 5 to get x equals 0. From the second case, we already have x equals 0. So again, we have the same solution from both cases. This tells us that x equals 0 is a double root of our equation. Therefore, the equation negative square root of 5 times x squared equals 0 has the solution x equals 0, which is a double root. Welcome to this video where we'll learn about double roots in quadratic equations. Today we'll examine a special condition for when a quadratic equation has a double root. Let's first understand what a double root means. A quadratic equation typically has two roots or solutions. However, sometimes these two roots are exactly the same value. When this happens, we say the equation has a double root or a repeated root. Now, let's understand the condition for a quadratic equation to have a double root. For a quadratic equation in the standard form ax squared plus bx plus c equals 0, the condition for having a double root is that b equals 0 and c equals 0. Let's understand this visually. When we have a quadratic equation with a double root, we can write it in the form a times quantity x minus r squared equals 0, where r is the double root. If we expand this, we get ax squared minus 2a, rx plus a, r squared equals 0. Now, let's work through an example problem that's similar to the one in our image. Consider the following quadratic equation. 7x squared plus quantity m plus n minus 5x plus quantity m minus n plus 7 equals 0. For what values of m and n does this equation have a double root? Let's solve this step by step. According to our rule, for a quadratic equation to have a double root, we need b equals 0 and c equals 0. From our equation, we can identify that a equals 7, b equals m plus n minus 5, and c equals m minus n plus 7. Now, let's apply our double root condition. First, b equals 0 implies that m plus n minus 5 equals 0, which simplifies to m plus n equals 5. Similarly, c equals 0 means m minus n plus 7 equals 0, which gives us m minus n equals negative 7. Now, we have a system of two equations with two unknowns. Let's add these two equations. Adding m plus n equals 5 and m minus n equals negative 7, we get 2m equals negative 2. Therefore, m equals negative 1. Now, substituting m equals negative 1 into m plus n equals 5, we get negative 1 plus n equals 5, which gives us n equals 6. So, our solution is m equals negative 1 and n equals 6. Let's verify this by substituting these values back into our original equation. For the coefficient b, we get negative 1 plus 6 minus 5, which equals 0. For the coefficient c, we get negative 1 minus 6 plus 7, which also equals 0. Therefore, the values m equals negative 1 and n equals 6 ensure that our quadratic equation has a double root. Let's summarize what we've learned about double roots in quadratic equations. For a quadratic equation, ax squared plus bx plus c equals 0 to have a double root. The condition is b equals 0 and c equals 0. This corresponds to a factorized form of a times quantity x minus r squared equals 0, where r is the double root. We solved an example where we found the values of m and n that make the given quadratic equation have a double root. Remember that a double root means the equation has exactly one solution with multiplicity 2. Welcome to this math video. Today we're going to explore a special case of quadratic equations that leads to an interesting result. Let's look at an example. What happens in a quadratic equation when all coefficients are 0? In a standard quadratic equation of the form x squared plus bx plus c equals 0, let's consider what happens when a equals b equals c equals 0. When all coefficients in a quadratic equation are 0, the equation becomes 0 equals 0, which is true for any value of x. Let's substitute these 0 values into our quadratic equation. We get 0x squared plus 0x plus 0 equals 0. This simplifies to 0 equals 0, which is always true regardless of what value x takes. Let's visualize what this means. When graphed, a standard quadratic equation typically gives us a parabola that crosses the x-axis at specific points. These are our solutions. For example, a normal quadratic equation like x squared minus x minus 2 equals 0 gives us two specific solutions. But in our special case where all coefficients are 0, we don't get a parabola at all. Instead, every single point on the x-axis is a solution. This means any real number can be a solution to our equation. In other words, the solution to this equation is the entire set of real numbers. We can express this using set notation as x belongs to the set of all real numbers. This is quite remarkable. When all coefficients in a quadratic equation are 0, instead of having no solutions, one solution, or two solutions as we typically expect, we have infinitely many solutions. Every real number is a solution. Let's verify this with a specific example. If we substitute any value, say x equals 5, into our equation, we get 0 times 5 squared plus 0 times 5 plus 0 equals 0. This simplifies to 0 equals 0, which is true. We would get the same result for any value we substitute for x. This confirms that every real number is indeed a solution. So what does this mean in practical terms? This special case shows us that when all coefficients are 0, the equation imposes no constraints on the value of x whatsoever. It's like asking what numbers when multiplied by 0 give 0. The answer is all numbers, because 0 times any number is 0. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.